Hello everyone, this is Mtobis Mhlongo, your mathematics and physical science tutor, and today I want us to look at one of our video that we posted that we're going to be doing content on trigonometry. And today our focus is mainly on the definition of the signs of trig ratios, which is definitions of basically trig ratios. So number A, we introduce definition of trig ratios. Definition of trig ratios. How do we define these trig ratios? So we take what they call a terminal ray of the coordinate x and y, which makes a right angled triangle here and has the angle theta, which is coming from the x-axis all the way to the side that is some form of a radius. If we were to make a circle around here, yes, my circle is not circling, and this is center 0 0, and this is coordinate p, such that OP is our radius if this is a circle, and also this is our y value and our x value from here to here. Now, to define the trig ratios, we look at the angle POX as the angle theta, and OP is equal to R. And we can define about 6 trig functions. Now those trig functions, this is valid actually for grade 10, 11, and 12. The trig functions we're going to look at is the 3: sine, cosine, and tangent, of which in short then becomes sin, cos, and tan. Now, I like to define all trig functions and call them sine of an angle. Sine of an angle. Why? Because the angle that this terminal ray, which we have here as theta, can be any Greek alphabet, alpha, beta, k, z, can be any Greek alphabet because it's an angle. So it's sine of an angle, then I call that angle. But in this case, we are able to call this sine of an angle theta, and this cos of an angle theta, and tan of an angle theta. Now, in short, you will find two mnemonics. Firstly, it's the SOHCAHTOA, and another one called CHACHOTAO, which some people like using. Now, with SOHCAHTOA defines the trig function as sin is the opposite side, sin of an angle theta is the opposite side over the hypotenuse side. But have we defined what is the opposite side? Now, if we want to define hypotenuse, opposite, and adjacent, we have to look at how the circle that I've drawn is made. Now, this circle that I've drawn in the right angle triangle, what we look at here is the angle. Now, if you have written this down, you are going to tilt that this point here points towards you, and such that what you see is opposite to you and the angle. So we call this side the opposite side because of that. And the angle in here is formed at the adjacent of the x-axis. So this side becomes adjacent. Then this is the hypotenuse. Hypotenuse. And that is how we come up with defining all those three sides. And if it's according to variables, we use x, y, and r. So we now can define according to the right angle triangle formed there in that circle or terminal ray. For cos, we can say, since it's cos of an angle theta is equals to the adjacent over the hypotenuse, and then tan of an angle theta is equals to the opposite over adjacent. Now, if it's according to variables, you saw here that the opposite side is y, the hypotenuse side is r, and the adjacent side is x. So if it's according, defining the trig ratios according to variables, opposite side is a y over r, adjacent side is an x over r, and then the opposite side is a y over x. Then we need to make a rule that x cannot be equal to 0 and r cannot be equal to 0, because if those are 0, then they can be undefined, which means those trig functions do not exist, or those trig values do not exist. They are undefined. Yes, I did say that there are 3 of them, but we can then define furthermore 3 that are called the reciprocals, which is cosec, secant, and cotangent, of which in short, cosecant, this one is cosecant. In short, this becomes cosec of an angle and sec of an angle, then cot of an angle. Now these are called the reciprocals. If I were to check a dictionary's definition of a reciprocal, let me quickly do that. A reciprocal, what reciprocal meaning? A reciprocal, it's simply dividing 1 by a given number or 1 by a given value. So if we divide, before we get to division, the trick here with reciprocals is that we look at the third alphabet, and the third alphabet. This will tell us what value has been divided, of which here it's not a value, it's a function. The function that has been divided by 1. So this means 1 over the function that starts with s, and this means 1 over the function that starts with c, and here it's 1 over the function that starts with t. These are reciprocals of the functions of trigonometry. So therefore, they follow the rules of these trig functions that we named here: sine, cos, and tan. Now, so it means they will also follow the terminal ray with an angle theta here, theta and theta. So therefore this is 1 over sin theta. This is 1 over cos theta. And this is 1 over tan theta. But we have already defined sin theta as what? 1 over sin theta, according to that mnemonic, is so, which means opposite over hypotenuse. And this one, it's 1 all over adjacent over hypotenuse. Then this one is 1 over opposite over adjacent. Now, once there is too many divisions, we need to operate with one division here. So this is 1 being divided by an opposite over hypotenuse. And this is, so I'm doing all 3 of them at once so that we can be short. And this is 1 being divided by adjacent over the hypotenuse. And this is 1 being divided by the opposite side over the adjacent side. Now, we also have to perform the reciprocal here, because once we change the division here into multiplication, we do the reciprocal, which means we're going to move the denominator to the numerator and the numerator to the denominator. Excuse me. Which basically means now this is hypotenuse over opposite, which is 1 times hypotenuse over adjacent, and 1 times adjacent over opposite. Basically, this is just hypotenuse over opposite, of which in variables, hypotenuse is what? R over y. Then this one becomes hypotenuse over adjacent, and in variables is just the r over x. This one becomes adjacent over opposite, which is basically just x over y. Then I'm going to rewrite them in summary, all 6 of them. That sin of an angle theta can be written according to the definition as what? As opposite over hypotenuse from our mnemonic so, ka, toa. And according to variables as what? Y over r. And cos of an angle theta as adjacent over hypotenuse, which is equal to x over r. Then tan of an angle theta as opposite over adjacent, because there's O and A and H, O and H. So we follow these. Here's my back here. We follow these first alphabet. It's OH, AH, and then OA. So this one becomes a y over x. Then they are reciprocals. Reciprocals, we have cosec, the angle theta, as 1 over sin theta, which is equal to r over y. Then we have sec theta, which is 1 over cos theta, which is basically r over x, and then cot theta, which is equal to 1 over tan theta, and that's equals to x over y. And that's how we define our trigonometric functions by definition. We'll continue with number B when we introduce the reduction formulas. Thank you for watching, and please like and subscribe and share.